Jamb 2026 candidates, you are welcome to today's lesson where we are taking progressive wave calculation. Another progressive wave calculation, we are taking angular frequency because Jamb, they repeat and well. Okay, if you need any assistance, you need last minute preparation plan, or you need any of my material, please endeavor to what? Contact me, all right? Contact me. Even though you have 1 week left to prepare for your Jamb UTME, I can still help you pass, okay? Don't be today I start the do, you don't take why I do. So contact me on WhatsApp for any assistance, okay? Mentorship and so on and so forth, what have you, all right? Do the right thing. Pass. I want to make you pass, Pass. I want to make you pass, all right? Let's go. So, under progressive wave angular frequency, there is something important that we have to know, all right? There is something very, very important that we have to know. We have a question here on the screen. The question reads, the equation of a wave traveling along the positive x direction, that's s as its direction, is given by y equal to 0.25 times 10 raised to the power minus 3 sine bracket open 500t minus 0.25 s bracket close. Determine the angular frequency of the wave motion. The same way we find waiting angular frequency. They told us to find what? Angular frequency. Angular frequency is this thing. It's like this. Something like this. Like nyash. So this one is angular frequency. Okay? In the wave equation. This one is angular frequency. So this is what they said we should find. So since this is what we want to find, and we were given a progressive wave equation. See the progressive wave equation where they give us. And they say the object, they travel where? Along a positive s. Okay, the object travel along positive s direction. Okay? So I want you to note something. Okay? In progressive wave equation, for a positive wave direction, use positive in the equation. That's use plus. Use plus. Okay? For a negative wave travel, in a negative direction, use what? Use negative. Okay? So here now is positive direction. So we are going to use plus in this. Okay? Okay, I'm just giving an instance. All right? So there are important things that we have to note here. First of all, let me consider this one. Okay? Let's write out the standard progressive wave equation. Okay? If you look at all the options here, all the options are given in rad second. Okay? Rad what? Second. All right? So let's write out the standard progressive wave equation. There are two progressive wave equations. You have this one, like this one that they gave us here. This one is the normal progressive wave equation that you'll be seeing lambda inside. This one is that I want to write now, the standard progressive wave equation. Standard progressive wave equation is giving us y equal to a sine bracket open, this thing angular frequency, this thing like nyash, t minus, depending, can be plus or minus. Okay, so plus or minus depending on the direction of travel. Okay, kx. Okay, bracket close. So this one is the standard progressive wave equation. You are going to compare this equation given to you by Jamb with this standard progressive wave equation. That's how you are going to find the answer. It's not hard. Okay, where y in this equation. Okay, no need for y. This y stands for the progressive wave. Okay, here now a is equal to amplitude. Okay, this one is amplitude. Okay, and this amplitude is usually the number before the sign or cos. Usually the number before the sign or cos. Okay, like here now, if you see here, this place, amplitude, this one is the number before the sign. So any number found before this sign, or if not cos, any number here, now the amplitude. Okay, then we have another thing again, is this one, this thing like nyash, angular frequency. Okay, this one is called angular frequency. Okay, angular frequency. And it is usually found where? Angular frequency is the coefficient. The coefficient of what? Coefficient of t. That's the thing. What appears alongside t is what? Is the angular frequency. For example, look at t here in the wave equation here. You see t here. Okay, what is beside t? 500. So this one is the angular frequency. Okay, let's now write another one again inside the equation. We have done a, we have done this one. Let's do k now. K next. K is equal to the coefficient. The coefficient of what? The coefficient of s. Okay, so anything with near s, now be k. Okay, anything with near s. For here now, waiting near s, so this one is k. This represents k in the wave equation. All right. So remember, this k is known as the wave number. Okay, wave number. That's what it's called, wave number. All right. Any other thing to look out for here? Any other thing? Okay. So the unit of angular frequency is rad Rad per second. This one is rad per second. You can see per second minus 1 raised to power minus 1. Then wave number, which is k, the unit is what? Rad per meter. Okay, so this one, rad per second, rad per meter. Don't forget to So what else do we have? The formula of frequency is what? When calculating progressive wave, the formula of frequency is what? Frequency is equal to angular frequency over 2 pi. So this one is the formula for frequency. Angular frequency over 2 pi. I just want you to understand the concept of this thing. Okay, so in this place, they told us to find angular frequency, which is this. Lambda, which is wavelength, is equal to, the formula of lambda is 2 pi. Know all this formula, 2 pi over k. Okay, then the formula of which other one again? What do we have here again? Okay, velocity in the wave equation, a progressive wave equation. Velocity is equal to angular frequency over k. Okay, or v can also be equal to f times lambda. That's frequency times wavelength, depending on what you are given. That's what we determine the formula that we use between two of them to solve for velocity. Okay, wave velocity. Okay, then one last one. Phase difference. Okay, phase difference. Phase difference is, this one is the symbol. Phase difference is equal to ks. Okay, or you can also use another formula. Phase difference is also equal to 2 pi what? 2 pi s over, is it lambda? 2 pi s over lambda. So all these are the formulas that you have to know about this progressive wave equation to make things easier for you. Now let's head back to our question. Okay, so in this our question, we have to note something very, very important here. Note something very, very important. First of all, we have to write out this wave equation given to us. When we write out the wave equation given to us, we will now compare it to the standard wave equation to look for whatever we want to find inside. The wave equation given to us is this. Okay, y is equal to 0.25 times 10 raised to power of minus 3 sine bracket open 500t minus 0.25 s bracket close. So this is the formula given to us. Okay, so let's now write out this standard wave equation and compare it. Okay, make comparison. Okay, the standard wave equation is y is equal to a sine, okay, bracket open, nyash times time minus k, which is wave number s. Okay, ks bracket close. So this is standard. We will now compare it with the standard equation. Okay, so let's do a direct comparison. Okay, here now, remember all this definition why I put for here, all this definition we did here. Now we want to use for here. That make you need to know all these things. Okay, so y is our progressive wave. Okay, sine a, what is supposed to be here? Sine a is what? So what we have here before this sine is what? Is amplitude. So our amplitude is equal to this. So amplitude a, wait, now cover here. So amplitude a is equal to 0.25 times 10 raised to power minus 3. Okay, then the next we have here is this thing like nyash, angular velocity. Okay, see sign, after sign, angular velocity, we don't enter bracket. Inside this bracket, angular velocity is what? The coefficient before what? T. Where is it? Angular velocity is the coefficient of t. That's close to t. That's close to t. We have 500. So angular velocity like nyash is equal to 500. You did see, huh? K is what? K is what? Is the coefficient of s. That's what you have beside or alongside s. That's the coefficient. Coefficient of s, that's this. CS here. What do we get beside s or alongside s? We get 0.25. So k is equal to 0.25. Okay, so that's k. Look at what we were told to find. Okay, angular velocity. This is it here. It is here, angular velocity, and we have compared the wave equation, everything. We don't compare everything, write everything, come out now. Imagine now say they tell us we'll find frequency. Now this formula will go apply. Or they tell us we'll find wavelength. Now this formula will go apply. Or they tell us we'll find velocity. Now this formula or this formula will go apply depending on what they give us this of. Or they say we'll find phase difference. Now this formula will go apply. So here now they say we find angular frequency. So you should know the answer now because we've seen the angular frequency daily. So our angular frequency, which is 500, yeah, the answer is 500. Angular frequency is equal to 500. Okay, 500. What is the unit? Remember the unit of angular frequency and wave number. Wave number is rad per meter, while angular frequency is rad per second. Look at it here. Look at it here. Here and here. Okay, so we are having what? Rad per second raised to power minus 1, or put minus 1 at the same thing. It's all algebra rule. Okay, any letter is believed to have raised to power minus 1. Okay, that's algebra rule. All right, you put them like that, or you put raised to power minus 1 at the same thing. Okay, so looking at the options, Is 500 there in the options? No, all the options are represented in standard form. So we convert 500 to standard form. Converting 500 to standard form with just one significant figure, we are going to put points here and we count 1, 2, 1, 2. So angular frequency is equal to 5.0 times 10 raised to power 2 rad second minus 1. All right. So among the options, pick the correct option and drop it in the comment section. Let's look at the next question.